Dear student, Assalamu alaikum. Today, class 10, subject physics, chapter number 12, geometrical optics. Topic of today's lecture is at 12.15 and 12.16 we will try to cover. And pages so far we will cover 59, 60, 61 and 62. These are the pages we will cover today. I repeat, class 10, subject physics, chapter number 12. The name of the chapter is Geometrical Optics. Topic of today's lecture are 12.15, which is the human eye, and 12.16 is the defects of eyes, defects of vision we will cover. And these two topics are on page number 59. We will start from 59, then we move 60, 61, and 62. This is the chapter we are doing, unit number 12, Geometrical Optics we are doing. And today's topic is the human eye 12.15 on page number 59. Please open page number 59 of your 10th class textbook. The topic we are going to start is 12.15. The topic name is the human eye. So we will discuss this. Please open page number 59 of your 10th class textbook for clear vision. I'm going to read this first for you and then I'll explain you. The image formation in human eye is shown in figure 12.35. This is a 12.35 figure. I introduce you with the component of the eyes, the parts of the eyes. First of all, before reading this, I will introduce you the parts of the eyes. What are the parts of the eyes? So, first of all, I will tell you the names of the component of eyes are. It has lens, eye has lens, and that lens is converging lens, type of converging lens. And the second part is iris, and the third part is, first of all, cornea, then iris, then lens, and then retina. These are the main parts of the eyes. What are they? I repeat, cornea. First one is cornea. This one, the curved one is cornea. And then we have iris, I-R-I-S, iris. This one, these two slanted lines, this is called iris. And the third one is lens. This one is the lens. This one is the lens. And we have a retina at the back. This is the back. At the back, retina is back at the back. I repeat, we have cornea, first component of the eye. Then we have iris. This one, the slanted lines, iris. And then we have a lens, and that type of lens is called converging lens. We have a one single lens in our eye that is of converging lens, and we have a cornea where the image is formed. Where the image is formed. The retina, sorry. This is retina where my image is formed. The human eye works same like as camera. We have in camera we have a film where our image is placed, where our image is made. But uh, here we have a retina where our image is placed. Okay, so in camera we have a lens. We have a lens over here as well. In camera, simple camera, we have a converging lens. Same, we have a converging lens in our eyes. So uh, we have two other things, cornea and iris, that control the lights entering into the eyes, and the iris control the is a colored one, and it controls the amount of light entering into the eyes. So I repeat it now. I read the image formation in human eye is shown figure 12.35. Human eye acts like a camera. I have, as I already told you, in place of the film, In camera we have a film, but here we have a retina records the picture. I told you retina. In camera we have a film where the image is formed, but in human eye we have a retina where our image we can see the object image is placed at the back of the eye is called the retina. So in camera we have a film, but in eyes we have a retina. In film, we image is formed, but in eye, we retina image is formed. On retina, image is formed. The eye has a refracting system containing a converging lens. I have already told you there is a single lens called a converging lens. A lens forms the image on the retina, which is light sensitive layer at the back of the eye. This is the light sensitive layer. Retina is the light sensitive layer. In camera, the distance of the lens from film is adjusted from proper focus, but in the eye, the lens changes focal length. Here, the lens changes the focal length, but in camera, the distance of the lens from film is adjusted for proper focus. We place the lens for we shift the lens, we change the position of the lens in camera, but in human eye, the distance proper, but in eye lens changes focal length. This lens, which is called the converging lens, change the focal length. Focal length, if we want to, I will explain you here how the lens change the focal length if he's seeing the distant object or if he's seeing the object that is close to the human eye. But now the iris is the colored portion of the eye and controls the amount of light reaching the retina. I have already told you there is the iris that controls the amount of light reaching the retina. It has an opening at the center of the cord pupil. The iris controls the size of the pupils. In bright light, iris contracts the size of the pupil. If we have a bright light, so iris contracts, the iris will contract the size of the pupil, which while in dim light, if we have a low light, very thin light or very dim light, then it is enlarged. Pupil is enlarged, but if we have a dark light, the pupil is contract. Pupil will contract, but if dim light, pupil will be enlarged. The lens of the eye is flexible and accommodates objects over a wide range of distance. So our lens, the only lens which is called the converging lens in our eyes, that is the lens of the eye is flexible. It is flexible and accommodates objects over a wide range of distances. We can see the objects in a young man. They can see the object, distant object, and the close objects very clearly. You know this. So I repeat, the human eye works like a camera. It has the parts. First part is cornea, and then iris, and then lens. We have lens, and the image is formed on the retina. Because in camera we have a film where our image is formed, but in eyes our image is formed on a retina, right? So cornea, the light enters through it. Iris control the movement, how much light is entering into the eyes, and then lens control the after passing through the lens, the image will be formed on the retina. Now I am moving towards accommodations. The camera focuses on the image of an object at a given distance from its moving the lens towards or away from the film. In camera, what happens? We focuses the image of an object at a given distance from its moving the lens towards or away from the film. So in camera, we move the lens position, uh, lens positions to see the object clearly, or um, to see to form the image, sharp image on the back of the film. So our lens controls that. In camera, our lens we move lens ahead and move away to see to get the sharp image on the film. But the eye has a different adjusting mechanism. But since why I'm taking the example of the camera, because camera works on the same principle as eyes, but there is a little bit difference in the eyes. here we have pupils, we have iris, we have a cornea, and we have retina. So in camera we have a film, and we have a lens, and it lens if we want to see the sharp image on the film, so we adjust the position of the lens, right? uh, Away or towards or away. So, but in this case, in the eyes, there is a different mechanism, adjusting mechanism for focusing the image of an object onto the retina. What is in eyes? Its eye ciliary muscles control the curvature and thus the focal length of the lens. There are the ciliary muscles present in our eyes. They control the curvature and the focal length of the lens. So they adjust the focal length of the lens and allow object at various distance to be seen. Object can be placed anywhere. It can be placed over here. 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 Our ciliary muscles control the curvature and the focal length of the lens and allow objects at various distance to be seen. If our eyes want to see the distant object or the object close to the eyes, so ciliary muscle control the curvature and focal length of the lens and allow objects at a very distance to be seen. In this case, image on retina will be formed relaxed because the object is lying very far away. In this case, our object is very far away, so the lens is relaxed because we are seeing the object at a very far away. So since the object is very far away, so our lens is relaxed, will be relaxed, and image on retina will be formed. If an object is far away from the eye, the deviation of the light through the lens must be less. So light will be less focus on the lens. So our lens will be relaxed. To do this, the ciliary muscles relax and decrease the curvature of the lens, thereby increasing the focal length. Whenever our eyes see the distant object, the focal length of the lens will be increased. Our ciliary muscle will be relaxed, our lens will be relaxed, or our ciliary muscle will be relaxed, decrease the curvature of the lens and increase the focal length. Whenever our eyes see the distant object, the focal length will be increased. The focal length will be increased. The rays and are focused onto the retina, producing a sharp image of the distant object. So we can see the distant object in this way. So there are the two things. One, the object is placed at very long distance, or at a distant object. Our eyes is seeing the distant object, the object which is very far away from the eyes. So in this case, because light will enter very less into the lens, and our lens will be relaxed. Our lens, if our eyes see the distant object, our lens will be relaxed. In this case, ciliary muscles of the eyes decrease the curvature of the lens and increase the focal length of the focal length, increase the focal length. So the second thing is our object is very close to the eye. In this case, uh, our lens will be tensed. You can see tense lens because our eye is going to focus the near object. That's why the focal length will be, radius of curvature will be increased and our focal length will be decreased. If an object is close to the eye, the ciliary muscle increases the curvature of the lens I have told you and shortening the focal length. The divergent ray from the near object are thus meant more so as to become the focus on the retina. So I have already told you there are the two things. In this case, in the first example, in the first figure, A figure, our eye, this is our eye. Our eye is seeing the distant object when the object is placing at a very high distance, or very object is far away from the eye, so our lens will be relaxed and ciliary muscles decrease the curvature of and increasing the focal length. Curvature of lens decrease the curvature of the lens and increase the focal length. So and the sharp image will be formed on the retina. As I have already told you, that our image is formed in eyes is on retina. And the next, where when our object is very close to the eyes, so our since it is very close to the eyes, so our lens of the eyes will be tensed, and in this case, focal length will be decreased and the radius of curvature will be increased. So these are the two things you got to understand. And dark image will be formed on the retina, and the sharp image will be formed on the retina. So, okay. Sorry, students. Uh, this is the thing we are going to discuss. Variation of the focal length of the eye lends to form a sharp image. Uh, sharp image on a retina is called accommodation. This is the definition of accommodation. I repeat the definition which is in the blue box on page number 60. The variation of focal length of eye lends to form a sharp image on retina is called accommodation. Since in both the cases I discussed in my when the object is placed at, at a far away, when the object is placed at the far away, and the object is placed at the when the object is placed close to the eyes. So the sharp image will be produced on the retina. Here the image will be produced. This is called accommodation. So we have near point and far point. So now I'm going to discuss near point and far point. When we hold a book too close, the print is blurred because the lens cannot adjust enough to bring the book into focus. This is our daily routine. If we bring the book very close to our eyes, it is a common practice. We cannot read the word. So the distance should be very at least 25 centimeters to read the word of the book. So whenever it is very close to our eyes cannot focus it, and we cannot even read the book. So this is the near point of eye is the minimum distance of an object from eyes at which it produces sharp image on the retina. So we have a near point and we have a far point. Near point of the eye is the minimum distance of an object from the eye at which it produces a sharp image on the retina. This distance is also called the least distance of the distinct vision. Figure 12.35. An object closer to the eye than the near point appears blurred. Then for people in their early 20s with normal eye, their near point is located at. If your age is 20 years old or less than 20 years old, your near point is located at about 25 centimeters. But when you goes older, your eyes it increased about it then near point goes to 25 centimeters to the 50 centimeters because for old ages your near point has increased. It's not 50, it's not 25 centimeters, it is now 50 centimeters when you at the age of 40 years, and to roughly 500 centimeters at the age of 60 years. And if you are at the age of 60 years, your near point is going to be 500 centimeters. But if you are at a 20 age, your near point is 25 centimeters. Near point is the where the when the object is placed, you can easily read the book. You can if you read the book, if you want to read the book clearly, your the distance from eyes to the book should be at least 25 centimeters. But if the young people have like their age is 20 years old, their near point is lying 25 centimeters. So if they are going to older, if we go at the age of 40 years, their near point is not 25 centimeters, their near point is close to the 50 centimeters. And if your age is going to be 60 years, then your near point is 500 centimeters. So this is the near point, and now I'm going to discuss far point. Far point of the eye is the maximum distance of a distance object from the eye on which the fully relaxed eye can focus. A person with normal eyesight can see object very far, such as the planet and star. The person whose eyesight is good, the person with normal eyesight can see object very far, such as planets, stars, and thus the far point located at infinity. The person who has a good sight, good eyesight, so they can see the planet like stars, etc. at a very at a very far point because they're lying very far. So they thus has a far point located at infinity because we cannot touch it. They are very far away from us. Stars and galaxies, the planets are very far away from us, so we can see them. Uh, and our young people have far point at located at infinity. So this is the difference near point and the far point. Now we discuss about 12.16 defects of vision. What are the defects? What are the drawbacks occurs when you go older? So what are the defects occur in the vision? Your right side goes on weak, going on weak. The inability of eyes to see the image of object clearly is called defects of vision. When you go older, I cannot see the objects clearly, and in like in early ages, some people have defects of vision. They cannot uh, uh, see the near things. They cannot see the far things. So this type of defects are called these types of visions are called defects of vision. So we have two types of defects. One is called the nearsightedness. The other name of nearsightedness is myopia, and the other one is we have farsightedness. The other name of farsightedness is hypermetropia. Now I'm going to discuss nearsightedness. How can we correct the nearsightedness? Some people cannot see distant objects clearly without the aid of the spectacles. You can see that some people cannot see the objects which are very far away clearly. If they have the glasses, they can see it, but without the glasses, they cannot see the object placing at far away. Object at if you are standing, if there is a tree at far away, they cannot see the tree because they must use the eyeglasses. They use the eyeglasses to see the distant object. This type of this defect of vision is known as short sight or nearsightedness. Other name of short sighted is called nearsightedness, and it may be due to the eyeball being too long. I explain you some people nearsightedness. What is nearsightedness? The other name of nearsightedness is myopia. Some people cannot see distant object. Distant object, the object which is far away. Some people cannot see distant object clearly without the aid of the spectacles. You might have seen in your family or somewhere. The people cannot see the distant object clearly because without the help of the spectacles, they in order to see the distant object, they use the glasses. So this type of vision defects of vision is called short sight, or the other name of short sight is nearsightedness. What is the reason behind it? Why they cannot see the distant object clearly? This is due to the eyeball being too long. The eyeball is too long. How can we now correct this type of defects of vision? Suppose this is a distant object and this is our eye. This is called point of nearsightedness eye, right? In this case, how can we calculate this? They cannot see the object over here without the aid of the glasses. So how they can correct the so that they can easily see the distant object. They put a the doctor put a lens that is called a diverging lens in order to correct or in order to see the distant object. The human being can see the distant object clearly. They put a diverging lens in front of the eyes. So when they place the diverging lens, so they after using the diverging lens, the people who has a problem in seeing the distant object, now they can see the object clearly. This was a defect before this. Before placing the diverging lens, the person cannot see the distant object. Now the doctor has put the diverging lens in front of the eye, so now the people has no problem in seeing the distant object. So how can they rectify this type of problem, defects of vision, by placing the diverging lens? They correct the nearsightedness. The other side of the called farsightedness. Defect of vision is called the farsightedness. The other name of farsightedness is hypermetropia. The disability of the eyes to form distinct images of nearby objects on its retina is known as farsightedness. When a farsightedness eye tries to focus on a book hold closer than the near point, it shortens the focal length as much it than the near point. It shortens the focal length as much as it can. However, even the shortest the focal length is longer than it should. Therefore, the light ray from the book would form a blurred image. So, if we this type of error is the in this defects of vision, the person cannot see the object very clearly when it is placing uh, clearly. It cannot see the object clearly when it is placing nearby to his eyes. So this type of defect is called farsightedness or hypermetropia, because the person has an inability to see the object lying close to his eyes. But in this case, this is called nearsightedness. The person has inability to see the distant object. Here, how we correct this type of defects of vision by placing the diverging lens. But in order to rectify or in order to in order to remove these defects, a person has which cannot see the close object near to it. The doctor place the converging lens in front of in order to rectify this type of defects of vision. So when we have a nearsightedness problem, the doctor places the diverging lens in front of the eye, or when the person who has problem in seeing the close objects, he cannot see the close object placing near to the eyes, the doctor places the converging lens in front of the eye. Here, diverging lens to correct the nearsightedness, to correct the farsightedness, or the doctor places the converging lens. This defect can be corrected with the this defect can be corrected with the aid of the suitable converging lens. The lens reflects the light rays and they converge to form an image on the retina. To an observer, these rays appear to come from near point to form a sharp visual image on the retina. So in this case, sharp visual image is formed on the sharp visual image is formed on the retina. Over here, always here image will be formed on the retina. So there are the two types of defects. The one is called the nearsightedness, and the other one is called farsightedness. In nearsightedness, the person who he cannot see the distant object very clearly, or cannot see the distant object clearly without the aid of the sunglasses, without the aid of the glasses. How the doctor correct this type of defects? They correct this type of defect by placing the diverging lens in front of the eye. So in this way, they can a sharp image will be formed on the retina. The other type of defect that is called the farsightedness, or the other name of farsightedness is hypermetropia. So in this type, the person cannot see the object close to, placing close to him. How the doctor correct this? They place, the person cannot see the object lying close to his eyes. He cannot see the, so without the help of glasses, he cannot see the object lying close to his eyes. How the doctor rectify this type of defect? They place the converging lens. As you can see, they place the converging lens in order to rectify the defects of farsightedness. So this is the end of the chapter, and this is the end of the topics 12 and 16. I hope students you understand this type of today's topics. If you have any question regarding today's topic, please feel free to ask. Thank you. Harun, do you have any problem? I I I realize that you during the lecture you have a problem. If you have any questions regarding today's topic, please feel free to ask. Or please unmute your mic and ask questions if you can. Ahmed, Shamsi,
No, sir, there's no problem.
Harun. Harun is talking. Ahmed, any problem? Ahmed, please ask question. So no one has any question. Thank you.